Welcome to the session on the binomial expansion, binomial estimation. The objectives for this session are to make approximations using the binomial expansion. Recall that the general term of the binomial expansion can be used to find individual terms in a binomial expansion. In the expansion of a plus b all raised to the power n, the general term is given by n choose r times a to the power n minus r times b to the power r, where n choose r is equal to n factorial all over r factorial times n minus r factorial. In science and engineering, it is often helpful to find simple approximations for complicated functions. If x is less than 1, then notice that x to the power n gets smaller as n gets larger. So in practical terms, for small x, you can ignore higher powers of x to estimate a value or approximate a function. Let's take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's tackle example 1a first. Find the first four terms of the binomial expansion in ascending powers of x of 1 minus x over 10 all raised to the power 6. So let's solve this. Notice that using the formula for the binomial expansion, we have that 1 minus x over 10 all raised to the power 6 is given by the expression shown on your screen. So in each term of the binomial expansion, we simply substitute in the values of a, b, n, and r. The values of a, b, and n stay fixed, but r changes. So a is equal to 1, b is equal to minus x over 10, n is equal to 6, and in the value highlighted, r is equal to 0. In this term, we have again a is equal to 1, b is equal to minus x over 10, n is equal to 6, and r this time is equal to 1. This time a, b, and n are the same as previously, and r is equal to 2. And here again, a, b, and n stay the same, and r is equal to 3. So tidying up gives us this expression. 1 to the power 6 is 1. The second term becomes minus 6 times x over 10. The third term becomes 15x squared over 100. And the fourth term becomes minus 20x cubed over 1000, and so on. Hence we've completed part A. Now let's have a go at part B. By substituting an appropriate value of x, find an approximate value of 0.99 to the power 6. So clearly we're going to be applying part A to part B. So let's solve this. From part A, we have an expansion for 1 minus x over 10 all raised to the power 6. In order to find 0.99 to the power 6, we find when 1 minus x over 10 equals 0.99. So let's rearrange to find x. So rearranging gives us that x is equal to 0.1, as shown. Now we can substitute in the equation from part A to give us that 0.99 to the power 6 is equal to 1 minus 0.1 over 10 all raised to the power 6. So substituting the value of x equals 0.1 into the binomial expansion gives us the expression shown. And so this is now approximately equal to 1 minus 0.06 plus 0.0015 minus 0.00002, which tidies up to 0.94148. So 0.99 to the power 6 is equal to 0.9415 to 5 decimal places. This brings us to the end of this session. If you have understood its contents, you should be able to make approximations using the binomial expansion. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.